Okay, well, keep going. Go. Oh, did it say you're running out of battery?
Yeah, it's got this little indicator that's
saying we're. Okay, I think I've got a charger here that I can just plug it in while it's working.
Speed it up a little bit.
The only problem with speeding it up once it's going is it's going to wreck our timing. But he's going just fine.
That's a good thing.
It did seem to slow down.
Oh, did it?
Yeah, like it was going good at first, and then it really slowed down.
Huh. I don't know, maybe the thing got... Yeah, try to keep it the same number of dots per dot. Just to see if I can charge it while it's working.
Well, no.
I don't know if that's going to work or not. Did it hurt you?
That's okay.
Stop spinning.
Oh.
Oh, it stopped spinning? Oh, I unplugged the thing. That's why. I got to plug it back in. Forgot that's what I needed that for. Okay. It should still be going, right?
Now it is.
No, I meant the
It's
liquid
not-
was still going down, wasn't
Yeah.
it?
It's just,
Yeah. Just wasn't being stirred.
Now, if you watch the pH over here,
I'm really interested in what's going on over there. I'll be back.
it's kind of, yeah, we might want to speed that up just a tad. Not that too much of a tad.
So that's what happened before. That should be good.
It's okay because
It'll
we're
slow
watching the level on his thing, so we will have a milliliters per second that we can use from what he's doing, even if the other stuff
okay,
doesn't
so-
work right.
Okay.
So that's why we're recording how fast it's going down. Okay, so what we're doing here is we're having a fight. We're having a fight between the OHs that come from the NH or ammonia, NH3 positive, and the hydrochloric or the acetic acid, H3O positive. So the positives and negatives are having what?
Oh, I was going to say, I think it's NH4.
NH4. What did I say? NH4
NH3.
positive.
You said NH3.
NH3 is the gas. NH4 positive is the ion. So what he's got going right now looks pretty linear, but that's the way it always starts out. Is that, and then you, as it goes along, you can lower it a little bit too.
We got to figure out the related rate, how fast he's got to bring this down.
Yeah, there you go. That would be a good thing to do. Hey, you're slowing down again.
You want me to speed her back up?
A little bit, yeah.
Ooh, we shook it.
Did we lose our water level? It's going to be coming out of the
I got it now.
out of the steel right now. Okay, so his line is still going almost straight across. So even still, we're at a pH of 4. Now it's slowed down to almost nothing again.
Oh, I think we should just keep it at like a nice stream. Otherwise, it's just going to keep slowing down.
Yeah,
Eventually, that'll slow down to drip.
it would be nice if we could fill it while it's working, but I don't know that we can.
We're going at a good rate now. We'll be out of gas soon.
And what's the pH level at, Vishai?
4.26.
Ooh. So apparently the hydrochloric acid is a much better acid than the ammonia is a
Vinegar?
base. Or vinegar. What did I say? Hydrochloric, didn't I? Okay, so temporarily take that out of there, and I'm going to add some more. Where'd my ammonia bottle go? And add some more ammonia water.
You want me to stop this?
Yeah, and then take that out of there because take this off the tray just so that when I pour this, and then get the towel on top of that stir because I'm going to spill. I'm just going to get this back
Where's
out.
that towel?
It's on the floor by the shy.
Oh, right there. Oh,
Okay. There you go. Oops.
oh, come on now, don't do me like that.
Yeah, I know. That's weird. Okay. Now you can put it back on there. Okay, start it up again. You're going to be fine. How you doing, Vishai? We're going to run out of time is the problem because we've only got 400. We're at almost 400 seconds and it only goes for 10 minutes. But it should be starting to. H is slowly rising. We're only up to 4.42. Ooh, you're slowing way down, buddy.
Man, it keeps on wanting to slow down. I don't know why though. I haven't quite figured that out yet.
Could be because there's less and less head pressure on the top. Slowing way down again. Try to keep it going. 4.5. Wish there'd be a way to extend the time. Let's see if there's a data. Extend the time. Is that one of the choices? Extend the time. Extend calculation, yes. Now we got it. No problems. Now, the reason why I'm doing this calculation is twofold. In 2 weeks, we're going to be making a graph just like the one that Yishai is making over here. But the other thing is that this is a logarithmic function, and there are very few logarithmic functions that are available. One of your assignments this weekend is to do, or the test is to do either an exponential or a logarithmic function from the data set. Well, there's one type, well, there's a couple titrations in there. But I'm giving you another one that we're going to analyze over the course of time. We won't finish it today, but you will, for the test, you will have a regular function, a trig function, and now either an exponential or a logarithmic. When we come back from our break, we're going to do the exponentials because they're a simple sign, I think. And he's up to 4.7. Now, sometimes people get nervous because it seems like it's, I'm going to experiment and extend the time a little bit more again.
Like it seems like there's an asymptote or something.
It seems like it's not speeding up very fast. Like it's oops. It seems like it's not progressing, but then all of a sudden it just zooms up. Now we're up to 1,500 seconds. If that's not enough, we're gonna 4.84.
We're
We're
going
gonna
down.
have to fill again.
Well, we're going down at a good rate. Unless you want to fill it up.
We might have to fill it up again because I didn't think that the vinegar was that much stronger than the ammonia, but it looks like we're going to need almost 150. You got a picture on it right now, right? So take it off the thing again and let's put in some more ammonia. Yep, shut it off.
And now it's shut off now, but once you add some, it'll probably start going. Where's that towel?
I don't know.
In that chair.
You want to throw that in?
You just are mad because I spilled. Try that. Okay. That thing is a little scary, isn't it?
I'm not worried about smelling like vinegar. I've got like a hot date or anything going on.
Are you sure? We could arrange that. I'm sure all the girls would just be.
I guess it depends on who I run into on my way back to the park.
That's true. That's true. It does. How's it going? Everything going good? Does everybody understand the concept? Because what we're measuring is concentration as a function, pH, as a function of time. But pH is a measure of the concentration of hydronium ions. And so right now, the vinegar is winning the battle. And as soon as it gets to what number?
7.
When it gets to 7, then the fight is even. And as we keep on going, then if it gets above 7, that means that the hydroxide or the ammonium.
So what you're saying is once it gets to 7, it's good to drink.
It would be excellent to drink because it will have a dissolved salt in it, and the salt that's dissolved will be ammonium acetate, because acetic acid is vinegar, and ammonium, so it'd be ammonium, the positive part, acetate. No, I have that backwards. Ammonium is H3O, no.
Ammonium is NH4
positive. It will taste
Like ammonia.
like ammonia.
It tastes like a pH of 7.
Like ammonia and vinegar. It's slowing down a lot.
I thought we were like on to like the next new sports drink or something like that.
Well, we could be. 5.38.
Put some of that
It's
in,
taken
put some of that in there. See what happens to the pH.
Yeah. So I did this at home, not using that stuff. I just kept on adding more vinegar. Oh, maybe I did it the other way around. I can't remember. But I just kept doing it, and it didn't take that many additions. I just would pour in a little bit more, and then I would watch what the pH did and see what happened. So I'm not sure what's going on.
The other way around, so the vinegar didn't take as much to.
I think I didn't start with 50 milliliters for one thing. I think I started with a whole lot less. But I didn't remember if vinegar was a stronger acid or if ammonia was a stronger base. And I knew I only had my Tupperware container full of vinegar, and I knew I had more ammonia. But it looks like I might run out of ammonia now, so I don't know what's going to happen. It's just a crapshoot, boys and girls. How you doing, B-Shy?
That's good.
What you got for a number?
6.04.
Does it appear like it's rising faster to you, B-Shy? Like the slope is increasing? Mm-hmm.
How many seconds are we at in this experiment?
We're over 800. We're at 803. Okay, now would be a good time for y'all to come and look.
We could probably
I'll run the camera while you go and look, Mike, because it's kind of interesting. We're hitting the spot. We're hitting the spot where things are happening in a hurry.
Oh man.
Yeah. Okay? And if you notice, it's not going down any faster, right?
No.
It's still going down the same. So it reaches that sweet spot where the battle is pretty close. Now think about why that is using the concept of pH. The concentration, remember, is always like 1/10. So we're getting close to a concentration of 1/10 of each. Now you're going to need to go back over and run your machines again.
I think we should submit this data to NASA.
I'm sure NASA would care. Hey, did you see what happened to that India probe?
Exploded.
If I speed this up, we're going to be just about it done.
Oh, we're almost done.
Yep.
It's
Took out their
past
orbit
7.
now.
So we've just run it down to 0, and then or whatever that is, 50, and then we'll stop. Okay? you don't stop. I just want him to stop so that, then maybe, yeah, let's stop.